So let's start things up. First, I'd like you guys to go on Google and search for download Android Studios. We'll agree to the terms and condition, download it and install it. You should be able to see this screen when that's all done. In this part, I'll take you on a tour of Android Studios. Android Studio is the official IDE for Android development. So let's start by creating a project. Start by selecting Start New Android Studio Project. Enter your name of the app, enter your company domain, and here you can see the package name, which is what makes your application unique from every other application on the App Store. So choose where you'd like to store your project, choose the version of the phone you want to target, and keep in mind the lower the API, the more devices you'll be able to target. So select a blank activity, and that's it, guys. You have your first application. Well done. So let's start the tour. This is the Android project view, and you can see all your project files here. Let's start by opening the manifest. Every application must have this. It provides info about your app to the Android system, such as the pages in your application, the style of your application, the current version of your application, the permission your apps will need, such as, let's say, permission to go on the internet, and also the minimum API your app requires. Let's go on the drawable. The drawable contains anything that can be drawn on the screen, such as an image, and all images you use on the app will have to go here, including the app icon. The menu file helps you define menu. I will go in your application, and you have to do this using XML. This allows them to be familiar and consistent across all Android devices. The layout file allows you to define the visual structure of your app. So while you write the code of your user interface, you'll be able to see the preview right here and change the device being used for the preview like so. There's another way of doing this programmatically, but we'll discover this later. So how do we add behavior to the layout which you will create? We do this in the Java file. In this part, I'll be showing you how to run your apps on an emulator and also on an Android device. So what is the Android emulator? It is a virtual phone that runs on your computer, and it lets you test your apps without using a physical device. To set it up, start by creating a default project. As you can see from the preview, the app should display Hello World. Click on the Tools tab, hover over Android, and then select AVD Manager. In this window, you can see all the emulators currently available, and you can also make changes to them. To create a new one, select Create Virtual Device over here. These are the available virtual devices as well as their attributes. I'll go for the Nexus S. Here you can select the version of Android you like your device to run on. Keep in mind, the lower the API, the faster your emulator should run. I'll go for 21, even if my computer isn't the best. Finally, enter the name of your emulator. That's it. Now, let's test it out. Run your app by clicking this play button over here. Select the emulator you want the app to run on. Wait for the emulator to set up. It might take a while for the first time. There it is, your first app. Now let's try running your app on a physical device. Enable USB debugging on your Android device. To do this, you first need to enable developer options. Enabling developer options is kind of tricky. Find the build number in settings. The location varies across different devices. This is how I do it on my Samsung S5. Tap it 7 times and you should receive a message telling you the developer option has been unlocked. Finally, allow USB debugging. Click the run button again, but this time you should see the phone listed here. Click OK. Your app should now be on your phone. In this part, I'll be showing you how to use XML to design your very first app. So what is XML? In Android, XML is used to describe how elements will be placed on the screen. Let's look at this more in detail. Create a default project. Delete the default code in the activity main. Each element can have several child elements, but there must be one element which is the parent of all elements. This is known as the root element. There are several choices for the root element, but in this tutorial we'll focus on linear layout. A linear layout is an element which organizes its children in a single column or a single row. We define the start like this and the end like this. All the children of the linear layout will go in here, and the properties of the linear layout will go in here. The first property we need to define is the namespace. It is a way of telling Android Studio the location of the elements we want to use in this layout file. We'll be using the default namespace. Another property we need to define is the width and the height of the linear layout. We want them to take up the entire space of the screen, so we use match parent. Finally, we need to tell the linear layout if it should place its children in a row or column. Let's put them in a row by setting the orientation to vertical. To test out this layout, let's give it some children. A text view is an element which simply displays a text. Create it like so. Notice I've used a forward slash and a greater than symbol this time. This is because our text view will have no children, unlike the linear layout. Adding text to the text view is easy. Simply change its text property. We need to add a height and a width to all elements we create in Android. So let's set the width and height again, except this time we won't be using match parent. Instead, we'll be using wrap content, which as the name suggests, will set the height and width to that of the text. That's it. Your text view is created. Let's create more children for our layout. Run it on an emulator, and you should see all the children should now be placed in a row. In this part, we'll experiment with linear layout by creating a login user interface. Let us examine the finished product. As you can see, the elements are added vertically, so we know the root element will be a linear layout with its orientation set to vertical. So let's create our linear layout. Define the namespace, the height, the width, and finally set the orientation to vertical. Next, we can see the first child of the layout is a username text box. It fills up the entire width of the screen, so we know its layout width will be match parent. In Android, we define a text box like this. An edit text element has no children, so we can end the tag here. Set the width to match parent and set the height to wrap content. Next, we need to set the input type of this edit text to text. This allows any character to be entered into it. The next child in the layout is a password edit text element. It also fills up the entire width of the screen, so it will also have a layout width set to match parent. Since it's a password field, we want the input to be hidden. Define another edit text under the one we previously made. Remember, since the linear layout is a vertical orientation, the elements will be placed on top of one another. Set the width to match parent and set the height to wrap content. This time, we need to set the input type of the edit text to text password. We're nearly there. The next child is a button. The button also fills the width. It is blue and it displays a text. This is how you create a button in XML. We need to set the width and height as usual. To make a text appear in the button, set the text property. Finally, to add a background color to the button, we need to first get the hex code of the color we want, then set the background color to this code. As you can see, the text is still black, which makes it hard to see. To solve that problem, I'll also set the text color to white hex. Run the application and you should now see your login user interface. We've learnt about linear layout, but that's not the only one. In this tutorial, we'll cover relative layout. So what is relative layout? The children of a relative layout are displayed relative to each other. So you can specify stuff like, hey text view element, always be to the left of this button view element. You can't achieve this type of control with linear layout. So let's start things off. Create a default project and you should see it should automatically create a relative layout for you. Delete the tool's namespace and the context. We'll cover them in future tutorials. Let us quickly run through its components. It has a namespace. As I covered before, this lets Android Studio know which elements we are working with. It has a width and height set to match parent, which means the children can take up the space of the whole screen. Something we haven't covered is padding. What it does is it creates a space between the children and the edge of the screen. So these will create a space of 16 dp to the left, right, top and bottom of the screen. That's all for our relative layout. Let's add some children. Create a text view and call it name. Make the height and width wrap content. Create another text view and call this one footer. Then an edit text which fills the width of the screen. Finally, create a button and make it wrap its content. As you can see, they've been added with no structure. So remember, in relative layout, structure is added by defining how elements relate to each other. We first have to give each element a name, and we do that by setting the ID property. Do that for all the elements. And now we can make this look good. Make the edit text always appear to the right of the text view like so. And now let's tell the button to be under the edit text. We can also tell the elements what to do inside the parent. For example, we can make the button align to the right, like that, and also make the footer text view align to the bottom too. In this tutorial, we'll experiment with relative layout to design this chat application. You need these two icons to begin. To download them, go on Google and search for Android icon generator. Find and download the send and person icon. Create a default project. When using pictures in your Android apps, remember that Android devices have varying screen sizes. To make sure your app looks good on all devices, different sizes should be created for each image. As you can see from the icons you downloaded, there's an image available for different variations of screens. Copy each of them into the drawable folder. Now we're ready to start designing the interface. Let's start with the profile icon, which is positioned on the top left. To display an image, we use an element called the image view. Create one like so and set the height and width to 50 dp. DP allows images to be scaled differently depending on the screen they are being displayed on. So for example, this image will look larger on a tablet compared to a phone. Set the source of the image view to the profile icon. The image should now display. Finally, align the picture to the top and then to the left of its parent. The next image we need to create is the send button on the bottom right. Create another image view with the height and width set to 50 dp. Set the source to the send icon. Now we need to align it to the bottom and then align it to the right. We are done with the images. Now we need to give them an ID to allow other elements to be positioned relatively. Create a text view to hold the contact name. Set the text size to 40 sp. sp is similar to dp but is scaled by the user's font size setting. So if the user decreases the font size, this text size will also decrease. Finally, align the text view to the right of the profile icon. We are nearly there. The final thing we need to do is for the chat app is create the input field. Create an edit text, align it to the bottom and then to the left of the send button. Set the hint to enter a message. The hint is what displays when the edit text is empty. That's it. Looking good, guys. In this tutorial, I'll give you an overview of an activity and how you can use them to make your designs function. Create a default project and now open the main activity Java file located in the Java folder. Delete this so we can focus on the important stuff. So what exactly is an activity? It is the building block of the user interface. It allows you to add user interactions to the elements you create in XML. An Android app can have multiple activities, but the main activity is the first one that runs. So to summarize, when your application launches on the device, the main activity will determine what will happen next. We write the instructions for what happens next in this block right here. So the first thing we are telling our app to do is to set the content view. To turn on a very useful feature which gives us details about the Android codes. For Windows users, open the Files tab and then select Settings, and for Mac users, open the Android Studio tab and then select Preferences. You all should be taken to this window. Enable Show Quick Dock. Now, if you hover over Set Content View, you should see what it does. It essentially displays the activity main XML file. This is why when we run the app, we can see our XML designs. If we were to remove this line and run the app, nothing will be displayed when the app opens. Create another activity by right-clicking on App Folder and then selecting New Blank Activity. Name it Second Activity. Now, how does an Android device determine which activity to run first? Head over to the manifest. You can see both activities, the main activity and the second activity. You should notice the main activity has an extra few lines of instructions. Hover over them to get more details. They essentially tell any device running your app which activity to run first. In this tutorial, we'll discuss the ability of an activity to store variables and how we can use them to control our application. So what is a variable? Variables store data in a phone's memory. The name of the variable is used to record the data whenever it's needed. I'll give you an example. Create a default project and head over to the main activity Java. To create a variable, first specify its type. We have a range of options, but in this tutorial we'll focus on the simple ones. An int can be used to store a positive or a negative whole number. So if we want to store the number 2000 in a variable, we'll define the type, the name of the variable, and then the value we want to store in the variable. Now 2000 is represented by score. If you try to store decimal number in an int variable, you'll get an error. This is because the int type can only store whole numbers. To store decimals, you have to use the double type. Now 10.2 is represented by measurement. Finally, we can store text in a variable by using the type string. The difference is when creating the variables, we use a quotation mark to hold the value of the string we want to store. So now Tonikami is represented by name. Notice there's a semicolon after every instruction. This is a requirement in Java. So why are variables useful? They can be used to store vital data your app needs, such as the current high score in a game. They allow us to manipulate the elements in our XML file. Head over to the activity main file, give the text view an ID, And now we can create a text view variable. Again, start by giving the variable a type, text view, then give it a name. Now we need to store the text view in XML in this variable. Find view by ID will find any element in activity main XML file. We just need to give it their ID. There's still an error. This is because find view by ID can find any view, such as an edit text or a button. We need to force it to only find a text view, and we do that by placing this right in front of it. Now we have a text view stored in this variable. We can do cool stuff such as change the text to that of the variable we defined up here. Run the app. You should now see the text has changed to the value of the variable. So what is a method? Computer programs can have thousands of lines of instructions, and to make code readable, related instructions are grouped together in a method. When you call find view by ID, for example, the system executes several instructions before it finds the element of the specified ID. OnCreate is also a method that the Android system uses when this activity is created. You will now learn how to create your own methods. There are two types of method we will be examining, one which returns a variable and one which doesn't. Find view by ID is an example of a method which returns a view, and onCreate doesn't return anything. I'll create a simple method called delete video, so all the instructions involved in deleting a video can go in here. The public means other activities have access to this method. The opposite to that will be private, which means only this activity can use this method. The void means this method will not return anything. Finally, we give the method a name followed by parentheses. Let's put some instructions in this method. Log.v is used to display a message when your app is running, so these messages should now display when this method is called. Now create another method called getName. It is now set to private, so only this activity can use this method. The void has been replaced by a string, which means this method must return a string. There's still an error with this method right now because we have said it is returning a string, but we haven't actually returned anything. We can return a string by first creating a string variable, giving it a value, and then finally returning it. To use this method, write the name of the method followed by parentheses. The problem now is getName is returning a string, but we are not using it. Create a variable to capture the string returned. Finally, log the return name. So to summarize, when the app runs, all the actions are performed in the delete video method, and the return name variable will hold the string the getName method returns. Run the app, and you should now see in the logcat that all the instructions in delete video are executed and the getName method returned the right name. That's it for this tutorial, guys. Thanks for watching. Create a project and set the ID of the text view to hello world. Now head over to the main activity Java file and create a text view variable. And using the ID we just set, find the text view and store it in the variable. Now create a method and call it change text. We want this method to change the text of the text view, and if we simply write the name of the variable, you'll see there's an error because this method does not have access to it. In fact, any method you create won't have access to this variable, only the onCreate method does. The general rule is you can only access a variable within the curly braces it is created in. That's why the hello world variable can only be accessed here. So how do we create a variable that can be accessed anywhere in this class? Following the general rule, we have to create it within these curly braces. So initialize the hello world variable up here instead and give it a value in onCreate. Now you can access the hello world variable in this method. Change the text to goodbye world and make sure you call the method in onCreate. Now run the program and you should see the text has changed. Let's create other methods to manipulate the hello world variable. Create a change color method, and in this method we want to change the color of the text. Find the hex of the color you want to change it to and change the color like so. We use color.parseColor to turn the hex into a type accepted by secTextColor. Create another method and call it change size. Change the size of the text to 50. Run the program and you should see the color and the size of the text is changed. Variables that are declared outside all methods are called member variables, and in the next tutorial we'll be using them to make an interactive application. I'll be showing you how to make an app that a user can interact with. Create a project and head over to the activity main XML file. Now this will be a simple app where the user can increase or decrease a number by 1. Create a text view and set the text to 0 and set the ID to output. Now create two buttons, set the text and the ID of the first button to increase, and finally set the text and ID of the second button to decrease. Now we are ready to create our application. Head over to the main activity Java file and delete the default code. First, we need to create a member variable which will hold our text views and buttons. Now store the increase button in its variable, the decrease button in its variable, and finally store the text view in its variable. Now, how do we know when the increase or decrease button has been clicked? The answer is methods. You can create a method that when either of these buttons are clicked, the methods will be called. Let's create a method for the increase button. It is public because the method will be called by another class that has detected the button click. Now within the parentheses, write view space v. We'll discover what this means in the next part. Now create the same for the decrease button. Now we need to tell the buttons which methods to inform when they have been clicked. Head over to the XML file and set the onClick attributes for each button to the correct method. The final thing we need to do in this tutorial is add 1 to the text views when the increase button has clicked and take away 1 when the decrease button has been clicked. Let's start with the increase button. Create a variable that will store the current number in the text view. .getText is used to get the text in a text that the text view holds. However, there's a problem with this because .getText returns a string. We need to convert the string to an int, and we can do that using integer.parseInt. So now we have our number and we need to add 1 to it, then display it in the text view. Now remember, we cannot display ints directly in the text view, so we have to convert it to a string by adding plus followed by double quotes. Repeat the same thing for the decrease method, except this time take away 1, run the program, and you should see it works. We previously discovered how to create an onClick method. It looks like this. Now the difference between this and the methods we are used to creating is that it has a parameter. A parameter is a way of giving more detail to a method before its instructions are performed. I will now show you how to create your own methods with parameters. Create a blank project and create 2 edit text. Give them an ID of input 1 and input 2 respectively, and then create a text view and set the ID to answer. Finally, create a button and set the ID to calculate. Set the onClick attribute to calculate clicked. Now head over to the main activity and store the 4 views we have just created in the member variable, and create the calculate clicked method, which will be called when the button is clicked. Now let's say we want to add 2 inputs and display the answer when the button is clicked. We can create a method called addition that will do this for us. It's private because we only want this class to have access to it. We can tell this method the 2 numbers we want to add by using parameters. The first number will be an int and it will be called num1. The second will also be an int and it will be called num2. And you can request even more data by separating them with commas. But in this scenario we only need 2. Finally, display the addition of the numbers in the output text view. If you now call this method, it will request num1 and num2. Give it the number in input 1. Remember, we spoke about converting a text to an int in the last tutorial. Then finally give it the number in the input 2. To summarize, when the calculate button is clicked, the calculate clicked method will be called. We will take the text in the input fields, convert them to numbers, and then send it to the addition method, which will add the numbers and then display it in the answer text view. Run your application and test it with multiple numbers and you should see it works. Decision making is very important in applications. An example of a decision your future apps might make is, do not allow this user to log in because they've entered incorrect details. Conditional statements such as if statements are used in Android to achieve this control. In this tutorial, we experiment with if statement by creating a number guessing game. Create an edit text and set the ID to input, and then create text view with the ID set to message. Finally, create a guess button with the onClick set to guess clicked. Now head over to the main activity, create a member variable for the edit text and the text view, and assign both variables in onCreate. We also need a member variable to hold the number the user is trying to guess. Make the number 5. Now when the user enters a number and clicks the OK button, we need to check if their number is equal to the number to guess. This is where an if statement comes in useful. Store the number the user has guessed in an int variable, and remember to first convert it to int. An if statement is written like this. If the condition written in this parenthesis results to true, then instructions within the curly braces will be executed. In this scenario, the condition we are checking for is if the guess number is equal to the number to guess. We check equality by using 2 equal signs. Now if the condition is true, we want to change the text of the message text view to correct. For the guessing game, we also want to tell the user if their guess number is too high or too low. We can use an else if to achieve this. An else if will be checked if the condition above is not true. So let's check if the guess number is less than the number to guess. Now again, change the text to too low if that happens. Finally, an else is what happens if all the above conditions are false. It is written like this. And in this scenario, if all conditions are false, it means the guess number is higher than the number to guess. Print out message saying too high. Run your program and test it. You should see it shows the correct message. In this tutorial, you will create a calculator app using if statement. Let's get right into it. This is what your XML file should look like. Create 3 edit texts, give the first one an ID of num1, give the second an ID of operation, and give the third an ID of num2. Now create a button, make the text the equal sign, and set the onClick to equal clicked. Finally, create a text view and set the ID to answer. Now head over to the main activity Java file. The first thing you need to do is create member variables for the free edit text and for the text view, and then assign them in onCreate method. Now create the equal clicked method, which will be called when the equal button is clicked. Now we're at the same step. When the equal button is clicked, we need to create variables that will store the input numbers. Call the first input 1 and call the second input 2. Make these variables double to allow our calculator to work with decimals. Next, we need to create a variable that will hold the operation. The operation can be a plus, subtraction, multiplication, or division, so the variable has to be a string. Now we need to use an if statement to determine which operation has been entered. First, let's check if it is a plus. If the operation dot equals plus, then we want to display the addition of both inputs in the text view. Now repeat the same for subtraction. This time we display the subtraction in the text view, and then multiplication, and then finally division. Now we have a working calculator. Test out the calculator with different operation and numbers and you should see it works. That's it for this tutorial, guys. Thanks for watching.